Lesson 12.7 starts our recursive sequences. A recursive sequence is a sequence in which terms are defined using one or more previous terms which are given. Let me show you in problem number 1. It tells us that the first term in a sequence is 5, and then it gives us a formula to find any numbered term in the sequence. That a sub n would equal a sub n minus 1 minus 4. We want to find the value of the sixth term, a sub 6. And so if I were to try to do that, I'm going to do a sub 6 equals a, and I'm plugging 6 right here for n, so 6 minus 1 minus 4. That would mean a sub 5 minus 4. So I would have to take the fifth term minus 4 to get a sub 6. I don't know what the fifth term is. So this represents, right here, this a sub n minus 1 represents that we're going to have to use the term before it. So we're actually going to have to find these one at a time, unfortunately. So I'm going to take my a sub 1 is equal to 5. Then I'm going to find the second term in the sequence. This would be plugging into here. So a sub 2, n is 2. I'm going to have a to the 2 minus 1. Well, 2 minus 1 is 1. So it really tells me to take my first term and subtract 4. Well, my first term was 5. So really I just have 5 minus 4 means my second term is 1. Then I should be able to find a sub 3. That says plug in 3 for n. So it'll be a to the 3 minus 1 is 2. A sub 2 minus 4 means take my second term, which I already know I just found, was 1. I see it right here. 1. Subtract 4. 1 minus 4 is negative 3. Hopefully you see the pattern. Then I could find the fourth term in the sequence by making n be 4. So it'd be a to the 4 minus 1, which is 3. Subtract 4 from that. Well, my third term was negative 3. Minus 4 more would make negative 7. So once you figure out the pattern, then you know really what you're doing. You're just subtracting 4 and subtracting 4 and subtracting 4. Subtracting 4, that would be negative 11, and subtracting 4 would make it negative 15. So a sub 6 equals negative 15. It was an arithmetic sequence. All right, number 2, we have a sub 1 is 1. A sub n, so to find any number term, is negative 5 times a sub n minus 1. Here we see it again. Even though it's times negative 5, it's still saying that this is going to use the previous term. So there's no way we can go ahead and say what a sub 5 is. Because if I started doing that work, I would have a sub 5 equals, 5 is now our n value, so it'd be negative 5 times a to the 5 minus 1, which is 4. I'm going to have to know what the fourth term is to be able to get the fifth term. So I'm going to have to start at the front of my sequence and work one term at a time. So a sub 2, so now my n values are going to be 2, and it might even help having something like this, where you see what you're plugging in, would be negative 5 times a to the 2 minus 1, which is to the first. That would mean take negative 5 times the first term. Well, the first term was simply 1, so negative 5 times 1 would be negative 5. To find the third term, a sub 3, that means your n value is 3, would equal negative 5 times a to the 3 minus 1, which would be the a sub 2. That means take your previous term, your second term, times negative 5, and our previous term was negative 5. So that would be positive 25. And then once you know really what you're doing with the previous term, it's easy to see, hey, I'm just multiplying by negative 5. Multiplying by negative 5. Multiplying by negative 5. Multiplying by negative 5. So then you could go ahead and figure out what that is. 25 times negative 5 is negative 125. Times another negative 5 is positive 625 would be your fifth term. And number 3 kind of combines number 1 and 2 because I see 5 times that a sub n minus 1 again and then adding 3. So again, it's going to be another recursive where I need the term before it so I can see what the next term is. The good thing is we're only going to go to a sub 4. So if a sub 1 equals 3, and then I want to find a sub 2, the second term, I would plug that in as 2. It'd be 5 times a, 2 minus 1 is 1 plus 3. So my first term gets plugged in, it'd be 5 times 3 plus 3, which is 15 plus 3, which is 18. A sub 3, plugging in as 3 would be 5 times 3 minus 1 is 2, so I would take the second term and plug that in there. That would be 5 times 18 plus 3, and that would be 93. And then I'll just go ahead and do the math this way. 5 times, if my n is 4, 4 minus 1 would be a sub 3 plus 3. So I'm taking 5 times 93 and adding 3. Which gets me 468. So my nth term, my fourth term, sorry, is 468.